So, as we just noted, if we put a stationary charge inside of a magnetic field, the charge will not feel any force from the magnetic field. Magnetic fields look to align another magnet, so what is the alignment of a stationary charge? Okay, but what if that charged particle is moving? If the charged particle is moving in a magnetic field, now it can interact with the field and feel a magnetic force. So in the picture shown here, we have a positively charged particle moving to the right, and it enters a magnetic field pointing into the page. How do we know the field is pointing into the page? Well, the notation that we use is that if a vector is going into the page, then you see an X. It is like we are seeing the fins or the feathers of an arrow, so the arrow is pointing away from us, and if we see a dot with a circle around it, then we're seeing the tip of the arrow, so the magnetic field that we're looking at is pointing out of the page. So an X means that the vector is into the page. So we have a magnetic field that is going into the page, and the charged particle is moving to the right, perpendicular to the magnetic field. And now the moving charge will feel a force. It will feel a force when the motion of the charged particle is perpendicular to the magnetic field. So we see here that the magnetic field, or the magnetic force, or the Lorentz force, on the moving charge is the charge times the cross product of the velocity vector and the magnetic field vector. So this is similar to something we talked about back in 201 with torque. So the torque is the cross product of the radius and the force. So the cross product of the torque was perpendicular. So to have a torque, the force and the radius had to be pointing in different directions, and it's a maximum when the angle between the two is 90 degrees. The magnetic field works pretty much the same way. When the angle between the motion of the charge and the magnetic field is 90 degrees, the force is a maximum. When the angle between the velocity vector of the charge and the magnetic field is 0, then the force is 0. Remember, we talked about this idea that a magnetic field aligns with other magnets with that magnetic field. So the moving charge is kind of like a magnet, and when it's moving parallel to the magnetic field, it's already aligned, so it's happy and it does not feel a force. Or at least it does not feel a force. When the charge is moving perpendicular to the magnetic field, then the so-called magnet is out of alignment, so the field applies a force to try and put it into alignment. To think of this more mathematically, the magnetic force is the cross product of the velocity of the charge and the magnetic field, and then this is multiplied by the amount of charge. The cross product is a way of multiplying two vectors, where the magnitude of the vectors is multiplied by the sine theta of the angle between the vectors. So if the angle is 0, then the sine of 0 is also 0, and the force is 0. If the angle is 90 degrees, then the sine is 1, so the magnetic force reaches a maximum. If the angle is something else, well, then we multiply the charge times the velocity times the magnetic field strength, and then multiply that times the sine of theta, where theta is the angle between that velocity vector of the charge and the magnetic field. Okay, so our positively charged particle is moving to the right, and our magnetic field is going into the page, so the force is going to be perpendicular, and so in this case, the force is going to point up. So, how do we figure out which direction the force will go? At first glance, it kind of seems like it could go either way. So, the magnetic force is always perpendicular to the plane made by the velocity of the charged particle and the magnetic field. So here we see that the charged particle is moving to the right and sort of towards us, and the magnetic field is pointing at 90 degrees to that, and it's pointing to the right and also sort of away from us. So the magnetic force is perpendicular to that plane, and it points straight up. So what you see is that we have created like an XYZ axis, like the corner of a box, and when you have this sort of corner set up, we need to figure out which way the force points, which way does the z-axis points. To do that, we use our hand, and we use something called the right-hand rule. So to figure out the direction of the magnetic force, you point your finger like a gun. The pointer finger, the index finger, is pointing in the direction that the charge is moving. Now you point your middle finger in the direction that the magnetic field is pointing. You've made a plane with your pointer finger and your middle finger, so your thumb is now pointing in the direction of the magnetic force. Remember, you have to keep your pointer finger in the direction of the velocity. So this is the direction that the force will point if the charge is positive. If the charge is negative, then the force will point in the opposite direction that your thumb is pointing. If you want, you could also point your index finger in the opposite direction of the velocity if the charge is negative, and then you would use your right-hand rule the regular way. So yeah, you're probably going to need a bit of practice with this, so we'll have some questions for you to do here in the classwork. There are some different versions of the right-hand rule, but this is the one that I tend to use. But if you look up in other resources, you'll probably find something else. As long as the three vectors are in the right arrangement, though, then it's fine. Beware that one of the surprisingly common mistakes that occurs with this is that people use their left hand to solve it instead of their right hand, and then they get everything backwards. Usually it's because you're holding something in your right hand, like an exam or a calculator, so then you use the left hand, and so yeah, make sure you use your right hand when you do the right-hand rule. Notice here that if the charge of the particle is negative, then the force is in the opposite direction. So right now we have a positive charge that's moving to the right, the magnetic field is into the page, so our pointer points to the right, our middle finger points into the page, so our thumb and the magnetic force point up. For the negative charge, the force goes in the opposite direction because Q is negative, so it flips by 180 degrees. You can also point your pointer finger to the left, point your middle finger into the page, and then your thumb and the force point down. Okay, I guess I've got a couple to do here. So in the first one, the velocity is pointing to the left and the charge is positive, so that means my pointer finger points to the left. Now my middle finger goes up in the direction of the magnetic field B, and my thumb is pointing into the page, so that means the force is going into the page. Next we have another case where the charge is positive, and this one the charge is moving down. So my index finger points down, and the magnetic field points into the page. So I put my middle finger into the page, and from that I get the force pointing to the right, since my thumb is pointing to the right. Alright, so you'll have a few of those to do in the classwork. So you'll also have some problems where you'll want to calculate the force. Here we've got an electron is moving at an angle of 50 degrees from a magnetic field with a field strength of 400 millitesla. The velocity of the electron is 2 × 10⁶ meters per second, and we want to know the strength of the force. Well, the force is the charge times the velocity of the particle times the strength of the magnetic field times the sine of the angle between the velocity and the field. So it's sine 50 degrees. So to do that, we get 1.6 × 10⁻⁹ coulombs, our charge, times 2 × 10⁶ meters per second, the velocity, times the field strength, which is 0.4 Tesla, times the sine of 50 degrees, the angle between the two vectors. If we do that, we get 9.8 × 10⁻14 newtons. Notice the conversion from 400 millitesla to 0.4 Tesla, so you have to use Tesla. So that's really all you have to do. Multiply the charge by the force, by the magnetic field, by the sine of the angle between the two. So if the angle is 0, then notice the force is 0. If the angle is 90, then the force is a maximum and the sine is 1. Okay, so I think that's it for this week. You have a few problems to do and a homework assignment for Monday, so don't forget to take care of those. So good luck and take care of yourselves.